All right. Hi, everyone. My name is Fia Huck, and I will be doing the Sustainability Science Capstone presentation. We are a group of 8 very dedicated sustainability science students, and our faculty advisor is Jonathan Hollander. Our topic is Indian Point Decommissioning Risk Assessment. So first, let's start with some history. Indian Point Energy Center was a 3-unit nuclear reactor in Westchester County. It was previously owned by the company Entergy and was built in 1956 while operations started in 1972. Overall, they've been pretty good at monitoring radiation, and then they've been very transparent with the community about their processes. So Unit 1 was deactivated in 1974 due to a cooling issue, but Unit 2 and 3 were actually deactivated in 2020 and 2021 respectively. The entire plant shut down in 2021 and is currently being decommissioned, which includes transferring spent fuels, dismantling reactors, and dismantling buildings. And this process is likely going to take more than 10 years. So where do we come into this? So in 2020, the New York State Department of Public Service established the Indian Point Decommissioning Oversight Board. It was a board to look over and maintain the decommissioning process in general. They are our main client. So in 2021, Entergy actually sold the site to a company called Holtec, which specializes in decommissioning nuclear sites. So now Holtec is the one that's responsible for the decommissioning, and they report to the DOB. Again, where do we come into this? So the Decommissioning Oversight Board actually asked us to do a health hazard risk assessment of the Buchanan-Verplack Elementary School, an elementary school which is only 0.7 miles away from the decommissioning site. So as you would imagine, there are a lot of concerned parents and stakeholders that are worried about the nuclear radiation as well as other possible contaminants reaching the school. So essentially, our capstone project is conducting a health hazard risk assessment of the Buchanan-Verplack Elementary School. So how did we do this? We approached our health hazard risk assessment in 3 main steps. The first one was to identify the contaminants of concern. How did we do this? We studied. We studied a lot. We read many extremely long documents, but specifically we read standardized EPA risk assessments, safety assessments, decommissioning examples like Fukushima and Zion, just to get a better idea of how the decommissioning process works and what are the associated risks with it. We interviewed Holtec and other experts in the field as well, and then we looked at EPA standards, CDC guidelines, medical journals, to see what kind of baselines they had for their contaminants and what kind of probable pathways there are. We also looked at wind data from NASA, and we determined, based on all of our analysis, the main contaminant pathway for our risk assessment was wind. The second step was to look at available technologies and equipment. So monitoring equipment is specific to each contaminant of concern. So to recommend the best equipment, we looked into various factors, such as maintaining and installing the equipment, feasibility, is it user-friendly, does it have an app? We looked at the precision, sample times, as well as, of course, the CapEx, OpEx, maintenance, and replacement costs. And the last step was to come up with a monitoring plan scenario that included the equipments and what contaminant they were measuring. So what are our contaminants of concern? We narrowed down the list to 6 main contaminants, the first one being radioactive particles. So of course, this is decommissioning of a nuclear site, so there is risk for radioactive particles. But the period of concern is actually quite early. So most of the spent fuel is transferred pretty early on in the decommissioning process, which is also our case. And that significantly reduces the risk of radiation moving off-site. But we were also interested in other contaminants that aren't radioactive, such as particulate matter, PM2.5, PM10. The level of concern was also high, but the period of concern was actually middle to the end, because PM is usually released to into the air when buildings are being dismantled. We also looked at volatile organic compounds, VOCs, had a high level of concern, but the period of concern was early to end because they're usually released when you're using cleaning solvents, which are used throughout the entire decommissioning process. We looked at asbestos and fiberglass that had medium levels of concern, and the period of concern was also middle to the end because they're mostly associated with dismantling of buildings. Lastly, we looked at lead. The level of concern was quite low. We actually went to the elementary school and collected soil samples, brought them back and analyzed them at Lamont through X-ray fluorescence, and found that the lead levels were actually quite low. So now that we know our contaminants of concern, we know their baselines, and we know the equipments to monitor them, we came up with 3 monitoring scenarios and presented it to the client. The first one was a business as usual scenario. Second, real-time monitoring from PM and VOCs. And third, complete real-time monitoring. So in our report, we went into detail for each scenario about the list of equipment measuring each contaminant of concern, the layout of possible equipment locations, the CapEx, OpEx, maintenance costs for all the equipment, as well as policies and actions if measurements exceeded a certain baseline. And lastly, we presented our recommended scenario and why. So let's go over each scenario briefly. So the first scenario, as I mentioned, was the business as usual scenario. So look at the map. If you look at the map on the left, the blue outline is the Indian Point decommissioning site, and the green outline is the Buchanan Elementary School. There's a zoomed in version on the bottom left, and the purple outline is actually a middle school that we chose as a control site. It was roughly 5 miles away from the decommissioning site, and it is also zoomed in on at the bottom right. So just as the title suggests, scenario 1, business as usual, this means that there's no additional monitoring of PM, VOCs, or any radioactive particles. This means that we must rely on Holtec for their radioactive particle measurements, and there's no real-time monitoring for any COCs. So a very obvious pro for the scenario is essentially there's no cost, but a major con is without real-time monitoring for any COCs, you're exposing the community to threat. Scenario 2 was real-time monitoring for PM and VOCs. So this scenario consisted of outdoor air monitoring of both PM and VOCs in real time. It's shown by the red dots, if you can see it on the map. We recommended having at least one outdoor air monitor in each site, and we also communicated with a company that was willing to come help install and maintain it. We also recommended indoor air monitoring, which you can see by the blue dots, if you can see it. And we recommend that there are at least 4 air monitors in each wing of the building in the elementary school. In terms of radioactive particles, we recommend that Holtec actually install one of their air samplers inside the school, and they provide the school with a daily report of Reuters-Stokes data for radioactive particles. So Reuters-Stokes are monitors that are already measuring radiation around the site, but the report is currently available quarterly. So we recommend that Holtec work with their IT to produce a daily report of that data and provide it to the school. For lead, we recommend that the school send samples to an EPA certified lab every year. And for asbestos and fiberglass, we recommend that when Holtec detects asbestos on their site, they notify the school. And in that situation, the school will set up air samplers and measure asbestos during the duration of the abatement. For scenario 3, complete real-time monitoring, it is essentially everything from scenario 2, but also includes indoor air monitoring every classroom instead of every wing. It includes real-time radiation monitoring at the school with a user-friendly interface or some sort of software. And we have recommendations of the type of equipment to do that in our report. For soil samples measuring lead, we recommend twice a year instead of once a year. And we also recommend more scheduled air samples for asbestos and fiberglass. So which scenario did we choose? We immediately eliminated scenario 1 because it had no real-time monitoring. So the main debate was between scenario 2 and 3. And we chose to go with scenario 2, real-time monitoring for PM and VOCs. There are many reasons for this. First of all, in contrast to scenario 3's suggestion that they do real-time monitoring of radiation at the school, we suggest that the school collaborate with Holtec's robust and already established radiation monitoring program. Several reasons for this. First of all, at least more than half of the spent fuel has already been transferred at our site, which significantly reduces the risk of radiation. There's also, Holtec has many air samplers already in place measuring radiation, and the New York Department of Health actually also periodically measures radiation at that site. And Holtec has also been doing a pretty good job at monitoring radiation. So we think that installing an air sampler at the school, as well as getting a daily report of that radiation data, will suffice. Second, from our analysis, we found that PM and VOCs were the main contaminants of concern, and scenario 2 monitors were for both of them in real time. Third, scenario 2 is much more cost efficient. It is 12% lower than the total cost of scenario 3. And importantly, it has lower labor and knowledge costs. Now remember, this is an elementary school. So the elementary school staff are not trained to manage and use equipment. And so this scenario lowers the amount of samples and equipment and saves the time, energy of the school staff, as well as cost to hire a professional and to train them in the first place. So overall, we recommend scenario 2 for monitoring at the Buchanan Verplank Elementary School. And with that, thank you so much for listening. I'd love to take any questions.
Wait, oh, is it on? Hey, did you switch your control from the midterm?
Our control. Oh, so for the midterm, we actually didn't consider a control. We spoke to Dr. Daniel Walsh about it and in detail, and of course Jonathan, and then we decided to have a control more on the right side instead of across the Hudson. That's where we were thinking, but we didn't have a decision for that yet, because we thought that it would be more feasible to have a control that was also a middle school, as it is also a part of the school district, and it would be easier to place a monitor there. And it's also would help the middle school monitor for their PM and air as well. So yeah.
So just a quick question about the spent fuel. So you said that
Sure.
they transfer it, but my understanding is that it stays on site in a
Yes.
dry cast.
Yes.
Is the DOB, are they concerned about the long-term radiation from that spent fuel? And is there a component of this project that's like, in 10 years, you should do X, Y, Z, or are they really just focused on the decommissioning of the other parts of the facility?
So for our project in our scope, we mostly focused on the decommissioning aspect of it. And if there's a spill during the transfer, because to my understanding as well, it remains in the cask and it will be there for a longer period of time. So in our scope, we concentrated on the 10 to 15 years that they're going to transfer the fuel from the reactor first, and then from the pools to the dry casks, and then the dismantling of the reactors and dismantling of the buildings itself. So that was our scope. Yeah. All right. Thank you so much.